Jessica, and I'm also on the Fuselage team.
I'm Janae Day, and I'm also on the Fuselage team.
I'm Evan Briegel, and I am on the Fin team.
And I'm Aubrey Harrison, and I am on the Fin team.
In order to produce the Nosecone, SolidWorks flow analysis was first done. From this information, we're able to gather that the von Karman shape would be the best shape for our rocket. The Nosecone will be made out of 7781 fiberglass. The mold is made out of 3 3/4-inch MDF boards glued together, and it was routed with a CNC machine. It's approximately 12 inches long, with a 3.1-inch inner diameter. The payload will be held in the Nosecone shoulder using a cast aluminum part. This is the mold for our payload bracket that will fit on the blast plate inside the shoulder that can be taken out once it lands. In order to get the payload as close as we can to the GPS coordinates, we're going to utilize a steel parachute which will be attached to the payload bracket, this Bible-like feature. Before the fiberglass can be laid up in the MDF, first must be sanded, then sealed multiple times before a final sealing coat and a final sand.
We are the Fuselage team. In order to build our fuselage, we're actually using carbon fiber filament to wind around a mandrel. So we had to actually design and manufacture a mandrel. We have 2 pieces of it here. It is in process. It will actually make a 3-inch diameter circle, which comes apart so we can collapse it underneath the carbon fiber once it's made and hardened. It'll have some bolts in it, we unscrew it, it can collapse, and then we have our body.
So this is the electronics bay that we designed. We used it for our L1 and L2 certifications, so we designed it to slide in and out of here so we can use it for our rocket. And it has a GPS system and an altimeter here, so we can locate our rocket. Used with these batteries, and it will go in and out of our coupler, which will be made out of fiberglass so that the GPS system can transmit through. And that's all.
This is our filament winder. It's an X-winder machine. We're going to be using that to wrap carbon fiber around our mandrel. We're just deciding on which angles to wrap the carbon fiber in to give us the proper strength and stiffness we need for the rocket fuselage. Using software for the X-winder to determine each layer and the angles for that layer, for each layer.
We will have 3 fins for the rocket, all made from 1/8-inch thick G10 fiberglass. We will be using a Haas TM2 to machine these parts. There will be an 8-degree slope on each fin surface here, on each airfoil. There will be a symmetrical wedge shape for the cross section. The machining operations will start with an adaptive clearing to rough out the shape of each airfoil surface, followed by a parallel operation to smooth out anything that was left behind by that clearing operation. The hole here will be inside the body of the rocket after they're attached. This hole is just to center our machine tools and give them a point of reference that is the same on both sides, as we will have to run these operations on both sides of each fin. Once all of the operations are complete on both sides, a 2D contour will be done to cut out the shape of the fin so that it can be released from the blank and attached to the rocket. The G10 should be enough to handle the stresses and survive the flight. We only anticipate going about Mach 1, but if need be, we can and will lay up over the top with carbon fiber.
Like link that picture right there.
Delete.
Well, you're currently being recorded, so quite on set.
I don't want to do your weird like voyeurism videos.
Now just look up and start talking.
Oh, look at that.